Hope you have all watched the summary video that was uploaded for week 1 and 2. It dealt with some introductory aspects and the purpose of the choice of topics for week 1 and 2. What I have tried to do through this particular video is to give you a motivation for week 3 and week 4, the contents of week 3 and week 4. Okay. In week 2, we looked at principal features of premixed flames and diffusion flames and the difference between the two. In week 3, these notions will be formalized and will be used to derive what are called conservation equations. These are mathematical statements of conservation of mass, Newton's second law, and conservation of energy, which is also the first law of thermodynamics, resulting in a set of coupled nonlinear partial differential equations which represent the phenomena of reacting flows, which are the model for a reacting flow. When we solve these equations, we will get solutions for the density field, the velocity field, the temperature field, and the species concentration field for a complex combustion chamber, which might be in a solid rocket motor or a liquid rocket motor or a gas turbine afterburner. It does not matter. The principles of conservation of mass, Newton's second law, and conservation of energy applies to combustion chambers of all these propulsion systems, and that is the purpose of giving you a glimpse of how these conservation equations are derived, how they look, what are the limitations in terms of solving them. We do not have a general solution for it, mostly because of the complications introduced by turbulence, and all propulsion systems, well, let me not say all, turbulence is the norm in most of the propulsion systems, but there are exceptions, important exceptions, that we will see in the following weeks. Okay. So these conservation equations solution of these conservation equations will give you a very detailed picture, a point by point field description of the state of a combustion chamber. But sometimes we could also learn a little bit by applying these equations over extended volumes, by integrating these equations or looking at integral forms of these equations over an extended period of extended domain, and we could get some insights, and that is what is done in the second lecture of week 3, which is integral analysis of flame. Ideas from the previous week on premixed and diffusion flames, the principal features of premixed and diffusion flames will be extensively used during the integral analysis of flame. Okay. And this more or less completes with the end of lecture 2 week 3. We would have arrived at a point where all fundamentals, perhaps except interaction between turbulence and flame, except that topic, all other fundamentals needed for understanding processes in a propulsion system would have been introduced and discussed in a way where the principal features are emphasized, not so much the details, with the idea that once the principal features are understood, details can always be learned at a later point of time as and when required. Okay. And the lecture 3 of week 3, it is with that lecture the transition to looking at actual propulsion systems starts. Okay. And the first lecture in that series will be a short introduction to solid propellant combustion. Okay. In fact, in this lecture what is discussed is some very preliminary propulsion related, thermodynamics and propulsion related aspects of a solid rocket motor. This is where the notion of a characteristic velocity is introduced and its connection to equilibrium is discussed, and other ideas, basic ideas in solid propellant rockets are introduced. This completes week 3 and I will give you a description for week 4 in a later video. Thank you.